Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shen, coming to you live from Mayfield. And in this video, we're going to be working on that Tuesday warm-up. And so it says this: to solve the following equation and check your solution using the Desmos calculator. And so if you notice, you have the equation 4x plus 12 equals x plus 3. Again, you must understand that these are two equivalent expressions. So again, on the left side is one expression, 4x plus 12, and on the right you have x plus 3. So again, you're saying that these two expressions are equal. So to be able to find out what x is, again, just like we've been talking about, you're trying to unwrap or undo what has been done. So you're trying to find out what 1x equals. Since we have variables on both sides, again, we can subtract the lower coefficient, meaning this: you're trying to look for which coefficient is lower. Well, if I'm unsure, I can say, alright, I know that my one coefficient is a positive 4x. If you need to, you can draw that positive in there. So I can say, I know this is a positive 4x. Let me actually make it a little bit better. There we go, it's a positive 4x. And then what do I have right here? Well, if you look, how many x's do I have? I have 1x. And since it doesn't have a sign, we know that it's a positive 1x. Out of those two, which one is lower? We know that the coefficient positive 1 is lower than positive 4. So that's what we're going to subtract or take away from both sides. So I'm going to subtract 1x from both sides, and I end up with this. Let me actually draw the horizontal line going across. So now I have this. I'm going to say, alright, let me total up. Again, make sure you're seeing. Let me move this out of the way for a second. Maybe, there it is. I'm saying this: each of these sides is one expression. So whatever I do to one side, I have to do to the other. That's why we have those, those railroad tracks or those train tracks. You're trying to make sure that you have to do it to both sides. So I'm going to do, on the right side, 1x minus 1x is 0, plus 3 is 3, and then on the left side I have 3x plus 12. So now this is my equation: 3x plus 12 equals 3. I need to get rid of any terms that are not the variable terms, and so I subtract 12 from both sides. So I have minus 12. Whatever I do to one side, gotta do to the other. The 12s cancel out, and so let's see if we can copy and paste that. Yes, I can. And so I say, alright, what do I have on my left side? I have negative 9. On the right side, I have 3x. Again, we only do one operation at a time, but we do it to both sides. Everything else stays the same. So notice how, let me actually draw a little arrow. Again, notice how this 12 came down and this 3 came down. And then also notice this 3x came down. Now that we have all the variables on the left and all the constants on the right, we can divide by the coefficient. So we see that we have a positive 3, so that's what we're going to divide both sides by, because we're always aiming for 1x equals a value. So let me bring this down. So I have 1x and equals negative 3. Always circle your answer so that way you know you are correct. Just like we've been doing. Again, you can bust out that Desmos calculator. Let me see if I can bring this to the front. And so it says this. Again, you type it in just as it looks. So I would type in my first expression. I would say, alright, 4x plus 12. I type that in right here. And then I say 1x plus 3, which I type in right there. And we're saying, okay, I need to get these two values equal to each other. So as long as these two lines are equal, we know that this is our answer. So we know we are good. To also back it up using the model, again, just like we've been doing, be able to have an expression on the left and an expression on the right. So on the left, I have 4 positive x's. Again, use this key for yourself. Then I have 12 positive 1's. And I can kind of reorder those that way a little bit easier to see. On the right side, I have 1x, and I have 3 positives. Some people were asking this, they said, hey, what happens if I say, all right, well, I know that I have 3 positive 1's, and I have 1x. That's totally fine. Again, it's all on one side, so as long as you're on this side of the equal sign, you're totally fine. Again, these can kind of move anywhere on this mat as long as it's on the right side of the equal sign. All right, so we got 1x and 3 positives, and so this is my equation. And so now, again, to repeat the steps that we did, so let's actually go back, let's see what we did. So first step was that subtract x from both sides. So I'm going to add the opposite to both sides. Again, we're trying to make those 0 pairs, get all the variables on one side. Again, the 0 pairs go away, so I can cancel these two out, and what are we left with? We're left with 3x plus 12 equals 3. 3x plus 12 equals 3. Let me take a quick snapshot of this. That way I can see where we're at. Copy and paste. All right. So now, all right, so we're on this step right here. We have 3x plus 12 equals 3. So now we have to add 12 negatives to both sides. Say 1, 2, 3, and I can copy paste a couple times. Let's actually undo that. And copy, paste. Again, whatever I do to one side, got to do the other. Again, we now have some 0 pairs. Again, you can kind of put them on top of each other if you're using the tiles, or you can draw them right next to each other, pair them off, whatever works. Again, 1 positive, 1 negative cancels out. I think I had 1 too many. So let's see, make sure I have 12. Which I believe I need 1 more. Okay. So, again, I make my 0 pairs. Again, it's 1 positive and 1 negative cancel out. So, for instance, it looks like this. We should have 3x, which is what we have, equals a negative 9, which is what we have. So far we're good. So now, this is a little bit tricky part. Again, you can show division a couple different ways. Again, thanks to Juan, he said, hey, I can have my x spread out like this, and I can take each of these 1's, and I'm going to place them into it. So I'm trying to divide this 9 negatives into 3 equal groups. So again, I can just do 1 by 1. Like we had, and you can see, okay, hey, one of these x's contains how many negative 1's? It has 1, 2, 3, so 3 negative 1's for every x. You can also do it like this. So let me back up a couple times. You can also separate them like so, and then just circle your groups, meaning this. I have 1 group here, 1 group here, and 1 group here. Again, all we're saying is I have 1, 2, 3 equal groups of negative 3, and so that's why x equals negative 3.